Hey, we have here on the board today another integral from the MIT Integration Bee 2022. This is from Quarterfinals, Round 3, Problem 1. We have the integral from 0 to 1 of x to the fourth over the square root of 1 minus x dx. Okay, and you may notice this can be actually handled with the u substitution, right? If I just take my 1 minus x and make that my u, what'll happen is you'll end up with a polynomial in the numerator, and it'll simplify pretty nicely. What I want to do is something just a little bit different. What I'm going to do is I'm going to bring my 1 minus x into the numerator, so we'll have our x to the fourth, and when I write this in the numerator, this is a 1/2 power, so I'll just write it as minus 1/2. And just by doing that, at this point you may notice that this is actually in the exact right form for us to use the beta function. And just looking at this right now, you notice, okay, we have the x term, the 1 minus x, and from this we can easily calculate our z1 and z2 value. So like on the first term here, if we say that z1 minus 1 here equals 4, well, that means that z1 is just going to be 5. And then similarly for the z2 minus 1, equating it to this exponent, which is minus 1/2, we can say that z2 is going to be equal to just 1/2. And the really useful thing about using the beta function is once we have the integral in this form, we can actually go right to a solution in terms of the gamma function. And that's usually not too bad because with the gamma function, we can use the factorial to calculate it. So let's just use this form over here on the right and let's see what we're going to have, because we already found our z1 and z2 value. So we're taking this integral and we're going to say our answer is going to be gamma of z1, which is just 5, times gamma of z2, which is 1/2. And this is going to be all over the sum of z1 plus z2. That's going to be gamma of 5 plus 1/2. I'm going to write that as 11/2. Now from here, what I'm going to do is I'm going to use this formula over here on the left. And this is going to allow me to calculate the gamma function in terms of factorials. So let's just do that right now. So for gamma of 5, we're going to have n minus 1, or 5 minus 1 is going to be 4 factorial. Then gamma of 1/2, using this again, this is going to be minus 1/2 factorial, which we'll get to in a minute. And then this one's going to be actually 9/2 factorial. And then for 4 factorial, you can just multiply that out. 4 times 3 times 2 times 1 is going to give us 24. Now for minus 1/2 factorial, I actually did a video on this previously, and I'll provide a link to that. So I don't want to necessarily go through all the details, but there is a nice value for minus 1/2 factorial, and it happens to just be the square root of pi. And for 9/2 factorial, I don't think I actually had a video on this exact value. I think I had a video on 7/2 factorial, but the principle is the same. And I'll provide a link again to that video. But what that's going to allow you to do is just, even though it's a fraction, still use it like a factorial and write it as 9/2 times 7/2 times 5/2 times 3/2 times 1/2, all the way to minus 1/2 factorial. But we know what that value is. That's this value right here. And that's just going to be square root of pi. So it's useful with these half factorials to just use a known value, like we have this square root of pi, and that's going to allow us to simplify this. Well, now from here, the square root of pi's are both going to cancel. That's really nice to get that out of there. So let's see if we can kind of wrap this up. We have 24 here in the numerator. With all these 2's here, we can write this as 2 to the 5th and bring it into the numerator. So I'll write this as 2 to the 5. And then here we'll just have 9 times 7 times 5 times 3. Well, 24, I'm just going to rewrite that as 3 times 8. But I'll write my 8 as 2 cubed. And that's going to allow me to cancel 3's here. And then 2 to the 3rd times 2 to the 5th is going to give us 2 to the 8. And then if you multiply 9 times 7 times 5, you get 315. So our final solution for this thing is going to be just 256 for 2 to the 8th over 315. So that's it. Thought it was a pretty good use of the beta function. Pretty fun problem. So we'll stop it. Thanks everyone for watching today. Please like and subscribe, and have a great day.